A groundbreaking technique called PrintListener has been developed by American and Chinese scientists, revolutionizing the way we think about fingerprint security. This innovative method can reconstruct a person's fingerprint pattern by analyzing the sound produced when their finger swipes across a touchscreen, with fingerprint-based security technology rapidly growing and projected to reach a market value of nearly $100 billion by 2032. The discovery of PrintListener raises important questions about data security and privacy. The technique utilizes spectral analysis to amplify the weak sound of a finger rubbing on a touchscreen, and considers physiological and behavioral characteristics of users. Through statistical analysis and a heuristic search algorithm, PrintListener successfully reconstructed synthetic PatternMasterPrint prints. In realistic scenarios, this technology recovered partial fingerprints in more than 25% of cases and complete fingerprints in almost 10% of attempts. This surpasses the MasterPrint attack method, which relies on a random search for universal prints. PrintListener's success highlights the potential vulnerability in popular applications like Discord, Skype, WeChat, and FaceTime, which often involve swiping gestures. As we advance in fingerprint authentication solutions, PrintListener reminds us of the continuous need for enhancing security measures in our increasingly digital world. A groundbreaking technique named PrintListener has been developed by American and Chinese scientists, revolutionizing the way fingerprints are reconstructed. This method utilizes the unique sound produced when a finger swipes across a touchscreen, enabling the recreation of detailed fingerprint patterns. The PrintListener technology signifies a major advancement in security, particularly for fingerprint authentication systems, which are increasingly prevalent in today's digital world. The market for such solutions is projected to reach nearly $100 billion by 2032. However, this innovation also raises concerns about potential data leaks and privacy, as attackers could theoretically access a device's microphone to capture these sounds. The researchers overcame various challenges, including weak sound detection and user behavioral variations. By employing spectral analysis, statistical methods, and heuristic search algorithms, their success in reconstructing synthetic PatternMasterPrint prints and achieving significant recovery rates in realistic scenarios highlights both the potential and risks of this cutting-edge technology. PrintListener's ability to reconstruct fingerprints from mere sounds marks a significant milestone in biometric security, but also underscores the need for heightened awareness and protection against novel forms of cyber threats. A groundbreaking technique called PrintListener has been developed by a team of American and Chinese scientists. This innovative approach allows for the reconstruction of human fingerprints by analyzing the sound produced when fingers swipe across a touchscreen. This discovery has significant implications for the field of security technology, particularly in the realm of fingerprint-based authentication systems, as the market for such solutions continues to grow, reaching an estimated $100 billion by 2032. The importance of understanding potential data leaks becomes paramount. PrintListener utilizes spectral analysis methods to overcome challenges like weak sound signals from finger swipes and takes into account physiological and behavioral characteristics of users. Through statistical analysis and a heuristic search algorithm, the scientists were able to reconstruct synthetic PatternMasterPrint prints. In realistic scenarios, this technique successfully recovered partial fingerprints in more than 1 in 4 cases and complete fingerprints in almost 1 in 10. This achievement surpasses the MasterPrint attack method, which relies on a random search for universal prints. The development of PrintListener highlights the evolving landscape of security technology and the need for continuous innovation to safeguard data. A group of American and Chinese scientists have developed a technique, PrintListener, which allows reconstructing human fingerprints by analyzing the sound produced during swiping on a touchscreen. This innovative method could revolutionize fingerprint-based security technology, currently a trusted and widespread method. The market for fingerprint authentication solutions is expected to reach nearly $100 billion by 2032. However, there's a growing concern about fingerprint theft, leading to increased caution in showing hands in photographs. PrintListener's breakthrough lies in its ability to analyze the weak sound produced by a finger sliding across a touchscreen. Using spectral analysis methods and considering physiological and behavioral characteristics of users, the technique successfully reconstructed synthetic PatternMasterPrint prints and recovered partial and complete fingerprints in realistic scenarios. This achievement surpasses the MasterPrint attack method, which relies on a random search of universal prints. PrintListener's development highlights the need for advanced security measures in the face of evolving technological threats. A groundbreaking technique named PrintListener has been developed by a team of American and Chinese scientists. This innovative method can reconstruct human fingerprints by analyzing the sound produced when a finger swipes across a touchscreen. The technology, known as PrintListener, leverages spectral analysis methods to capture the unique sound patterns of fingerprints during touchscreen interactions. This advancement in security technology is significant, as fingerprint-based authentication systems are widely used and trusted. The market for such solutions is expected to reach nearly $100 billion by 2032. However, there's a growing concern about fingerprint theft and data leaks. PrintListener addresses these issues by providing a novel way to capture and analyze fingerprints based on sound. The technique has shown promising results with the ability to recover partial and complete fingerprints in realistic scenarios. This development highlights the importance of continuous innovation in security and privacy technologies in our increasingly digital world. A groundbreaking development in security technology, PrintListener has emerged as a novel method to reconstruct human fingerprints by analyzing the sounds produced during finger swipes on touchscreens. This technique, developed by American and Chinese scientists, leverages the unique sound patterns created by papillary lines of fingerprints during touchscreen interactions. The innovation holds significant implications for the fingerprint authentication market, projected to reach nearly $100 billion by 2032. PrintListener's effectiveness was demonstrated through tests, achieving up to 27.9% success in partial and 9.3% in full fingerprint reconstructions, from just 5 attempts, under stringent security settings with a false acceptance rate of 0.01%. The method overcomes challenges such as weak sound signals and user variability. Through spectral analysis, statistical methods, and heuristic search algorithms, the technology could potentially reconstruct synthetic PatternMasterPrint prints, outperforming traditional MasterPrint attack strategies. This advancement raises important considerations for mobile device security, especially for applications like Discord, Skype, WeChat, and FaceTime, which involve frequent swiping actions. PrintListener's ability to discreetly capture and reconstruct fingerprints from mere sound highlights a new frontier in security and privacy concerns in the digital age. A groundbreaking technique called PrintListener has been developed by a team of American and Chinese scientists. This innovative method can reconstruct human fingerprints by analyzing the sound produced when a finger swipes across a touchscreen. This discovery has significant implications for fingerprint-based security technology, which is widely used and trusted globally. The market for fingerprint authentication solutions is expected to reach nearly $100 billion by 2032. However, this technique also raises concerns about potential data leaks and the security of biometric data. The PrintListener method overcomes several challenges, including the weak sound of finger swipes and the need to account for physiological and behavioral characteristics of users. It employs spectral analysis, statistical analysis, and a heuristic search algorithm to reconstruct synthetic PatternMasterPrint prints. In realistic scenarios, this technique successfully recovered partial fingerprints in more than 1 in 4 cases and complete fingerprints in almost 1 in 10. These results surpass the MasterPrint attack, which relies on a random search of universal prints. This development highlights the need for enhanced security measures in our increasingly digital world, especially in popular applications like Discord, Skype, WeChat, and FaceTime, which are susceptible to such attacks.